all the same units. For instance, I'm not sure what this figure is called. It is two-dimensional. To get the perimeter, it's actually pretty easy, right? You can see that length here, the sides, they're all in centimeters. So the length of each side is measured in the same units, centimeters. So the perimeter, what do? You just add up the lengths. And again, that's the distance around the polygon. That's the distance around the shape. Again, if you imagine starting somewhere, walking in one direction along the boundary, like here, the perimeter is how far you walk. So in this case, the perimeter is this sum, which is 33 centimeters. So that's basically what perimeter is. That's one example. Let's do another one. Excuse me. So for this one, okay. So hold on, wrong set of notes that's posted. These are what I sent you, but I don't want those. Let me just get the correct ones. Here we go. Yeah, I shared the wrong thing by mistake. Here we go. Here we go. Okay. What I sent you, remember, was the outline of the notes. It doesn't have everything, so that's what I was sharing just now. So I meant to share these set of notes, so I apologize for that. So now for the next slide, if we want to get the perimeter here of this, right? Well, at first you might just think, okay, well, let's just add up the sides. But here, you can't just do that. And why is that? The units are not the same, right? Here we have centimeters. Here we have meters. I mean, you could convert from one unit to another one, to the other one. That we'll actually see in the next chapter, how you go from one to the other. But for now, we cannot get the perimeter. So again, the units, they're not all the same. Okay, let's just do a simple modification. Let's basically switch from meters to centimeters. So it's a new example. But now you can add up the side lengths. You can just do that. And how do I know that? Well, because the units here, they're all the same, right? They're all centimeters. So we can just add up the units. We can just add up the side lengths. And if we do that, we get this. You get 67 centimeters. So that's the perimeter of this polygon. It's a polygon because it's made up of straight sides. And it's closed, as I said before. Okay. All right, so we have that. That's perimeter. I mean, it's not too complicated, so I really don't want to spend too much more time on it. I mean, the idea is not that bad. So let me move on now to area. So area basically is how much surface the two-dimensional figure covers. Or if you want, you could think of it this way: how much two-dimensional surface the figure covers, okay? So you could think of it that way. Two-dimensional space, that's what I meant to say. It's how much two-dimensional space the figure covers. That's where area is. Now with area though, the units are a little bit different in that whatever unit you're using for length, the unit for area is going to be the unit for length squared. In other words, if you're, say, measuring in feet, length, so the length of each side is in feet. For area, the unit will be feet squared, like so. Some people also use square feet, which I'm pretty sure is the same thing. But if you go back to, let's say, this here, if we were going to get the area of this, the units for it would be centimeters squared. Because again, here we're using length, we're using centimeters. To measure length, we're using centimeters. Okay, so That's intuitively what area is. Yeah?
Why the square thing?
Why these down here?
No, like if you're going to measure it in feet, why you have to add like feet squared or like
That's just how area is set up. It's always
oh
square units.
oh
Okay? Good question. Does that answer your question or?
yes, sorry. Thank
Okay.
you.
You're welcome. It's just basic. It's just going to be in square units. That's just how area is. Later on, we'll actually get to volume. Volume is actually in cubic units. So again, that's we'll see later. We'll see near the end of chapter 1. So volume, for instance, will be cubic units. Here, area is just in square units. So that's what's happening here. Now, oh, sorry. Are there any other questions? Yeah, that was a good question. Okay. Now, there are different ways to actually get the area of something. I'm actually kind of illustrating it here. I think this is what they do when kids first, when are first introduced to the concept of area. You cover the polygon by squares, where each square is 1 square unit in area. And then you just see how many squares cover the polygon. That's what I'm trying to illustrate here. This is what the book does mention. This is not something I'm really going to emphasize, though, because we have a much easier method. Formulas. The formulas here actually give us the area of different polygons, different shapes, so to say, different two-dimensional figures. For instance, a rectangle where the base here, or this side has length b, this side length, we also call it the height, h. The area of this would be b times h, or base times height, or length, yeah. That's for a rectangle. And for a square, it's actually the same idea. Triangles, you have base times height, right? The area is 1/2 base times height.